Hello. Hello. Yeah, am I audible to everyone? I hope my voice is clear to you or is audible, right? So let's see who is going to join. Let's wait for peoples to come. Wait for 2 minutes and then we'll start. तो लास्ट टाइम हमारे कुछ क्वेश्चंस हम कर रहे थे, राइट? आईआईटी जैम की प्रैक्टिस सेशंस के रिलेटेड। तो आज भी हम कुछ वैसा ही करेंगे, राइट? तो कुछ और क्वेश्चंस मैं आपके लिए लेके आया हूँ और आज मैं आप लोगों को कुछ होमवर्क भी दूंगा जिसको आप घर पे बैठ के आराम से ट्राई करना, ठीक है? और प्रैक्टिस करना आराम से और जैम एग्जाम की अच्छे से तैयारी करना, राइट? बिकॉज इट इज वेरी इंपॉर्टेंट, बिकॉज वो जो एग्जाम के 3 घंटे हैं ना, वो आपके फ्यूचर डिसाइड करेंगे। दे आर गोइंग टू डिसाइड योर फ्यूचर। लेट्स सी हु इज गोइंग टू जॉइन दिस लाइव स्ट्रीम। या वी आर गोइंग टू स्टार्ट इन विद इन 2 मिनट्स। ओके। अगर कोई आपके एग्जाम्स के प्रिपरेशन से रिलेटेड कोई डाउट है, आप पूछ लो। ओके, अभी टाइम है हमारे पास। एंड दोज हु डोंट नो मी, लेट मी गिव यू माय इंट्रोडक्शन. Myself Nitish, I am from IIT Delhi, currently doing masters in physics. Okay, I cleared the JAM with all India rank 90. Yeah. I also cleared NGP examination top 1% in national level. Okay, and CUT, PG, and JEST. These all are exams that I cleared with good ranks. S- Let's wait for so that people can join. So how's your Diwali going, man? कैसी रही दिवाली आप सबको की? आई होप आप सबने एंजॉय किया होगा, पटाखे वगैरह बजाए होंगे, राइट? दिवाली कैसी गई? So I think let's start. Let's don't waste the time, right? So let's start. We will discuss it if you have any doubt or related to IIT-JAM examination or any anything related to JAM, we will discuss it later. Okay. Let's start our questions practice. राधे 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 भाई, राधे राधे. So I'm sharing my screen. Is my screen visible to everyone? Just tell me if it is visible, right? तो लास्ट टाइम हमने अराउंड 14 क्वेश्चंस कर लिए थे और लास्ट में हमारी मीन्स स्ट्रीम एक टेक्निकल प्रॉब्लम की वजह से एंड हो गई थी. सो तो आज हम कुछ और क्वेश्चंस करेंगे प्रैक्टिस सेशन से रिलेटेड एंड देन वी विल डिस्कस इफ यू हैव एनी डाउट. ओके, सो लेट अस स्टार्ट. We were at the question number. We have to start with question number 15. Okay, so just read this question. Just read this question and try to do it. It is from like Bragg's diffraction concept. A simple question. Try to solve it. So this question says an X-ray beam. There is an X-ray beam of wavelength lambda. wavelength हमें दे रखी है जिस that is 1.7 angstrom and is diffracted by a cubic KCl crystal. Right, the crystal which we are given is a cubic in the shape. Right, that means the all the sides are given with the A, let's say. So volume कितना हो जाएगा cubic cell का? That is A cube, right? It will be the volume of the cubic crystal. So and we are also given with the density, right? The density of the crystal is given. So can you tell me how can we find the density of any unit cell, right? So density we represent with by the rho. Getting my point? What is the what is density we usually represent? That is mass by volume. So what is mass? That is the n. That is the effective number of atoms in a unit cell, right? Into mass of a single unit cell. Sorry, mass of a single atom. Effect n is the effective number of atoms and m is the mass of a single atom, and divided by the volume. Volume of what? Volume of a single unit cell. And we are given with the side A. Let us assume we are given with the side A. So what if we are given with the side A? So what is the volume of the unit cell? That is cubic, and that is n into m upon a cube, right? So let's find out what is the going to the mass of a single atom in a unit cell, right? So we are given with some interplanar spacing. We will discuss it later. What is where we're going to use it? Let's first find out the mass. Okay, so glancing angle. We have to find the glancing angle for second order Bragg's diffraction from these planes, right? And we all know the Bragg's diffraction formula, na? That is 2d sine theta equal to n lambda, right? Where n represents the order, where n represents the order of the diffraction. So here it is, we are given the second order diffraction, second order, right? So n will be equal to 2, right? That is 2d sine theta equal to 2 lambda, right? And we are given with the wavelength lambda. We know what is the wavelength lambda. Okay, we don't need to take any kind of tension for that. We know the what is the going to be the value of lambda. Okay, and we need to find the sine theta, right? We need to find the glancing angle, that is sine theta. I mean, the theta we need to find. And how we can find out the d here? D is something like we are given with the cubic cell. So d is equals to a upon under root of h square plus k square plus l square, right? H scale, right? H scale are the million indices. We can find out that. And what are the million indices? That is 200. So what is the going to be value of d? A upon 2. Getting it? Just put the value of h scale there, and you will get what is going to the value of d. So this is our density, and also given there is a data given that the molecular weight of KCl is 74.6 AMU, right? So let's go to the next page. So we are going with the molecular weight. What is the molecular weight we are given with? Let's see, it is 74.6 AMU, right? And what can we do if we want to find out the weight of only single atom? Molecular weight is something like it is a 1 mole of atom. 1 mole of molecules are there. So this is the 74.6 gram is the weight of a 1 mole of atom. Okay, this is a mole. We can take it as a single molecule weight also, because it is given in the AMU. If it is in the gram, like 74.6 gram, then it will be considered as a weight of a 1 mole, weight of the 1 mole, right? If it is given in the gram, so we are going to take it as a weight of a single molecule, right? So what we are going to need to find out, we need to first find out the density is given, right? That is n into mass upon a cube. From that we can find out the value of a, right? This implies a cube is equals to n into m upon density rho, right? We are given with the density rho. We know what is the mass, right? We know what is the mass. From this we can know what is the value of n for a unit cell, cubic unit cell. What is going to be mass? Sorry, what is going to be effective number of atom? And we know for a given cubic cell, all the atoms are present on the corners. So each corner contribute to 1/8. right? Each corner can be 1 by 8, oh, right? So what are the effective number of atom it is for a, and it is like FCC structure, I think, right? And defective by crystal, yeah, it is a FCC structure. KCl is a FCC structure. So N is going to be 4 there. So 4 into mass we know 74.6. If we are going to take it in the AMU, we need to convert it into the gram. If we take it in the gram, then we need to divide it by the Avogadro number. So 6.626 into 10 raised to power 34, right? And we know it is 23, na? 10 to 23. And we know the density. Density is given as 1.99 into 10 raised to the power 3, right? In the question. So can you find out the value of A from here? What is going to be the value of A? If you calculate this, it will come out to be 0.249 into 10 raised to the power minus 27, right? Meter. Okay. And it is A cube. So meter cube. So just calculate the value of A from there. Let me do it for you firstly. Okay, let me do it. It is comes out to be 6.29 into 10 raised to the power minus 10 meter. So this is going to be value of A. We have found out the value of A. We know the what is the value of A. Now can we find out the value of D? How we can find out we can find out the value of D from here, right? Just put the value of A here. You will get the value of D, right? If we find out the value of D, we can easily find out the value of theta from here. So just find out the value of D from here. Just put 6.99 into 10 raised to the power. What we get? What is the D? That is minus 10 upon 2, right? It is approximately 3.145 angstrom, right? This is the value of D. Just put the value of D here. We will get sine theta equal to lambda upon D, right? We are given with the lambda that is 1.7 angstrom. And what is the value of D we just found? That is 3.145 angstrom, right? So just find out the value of theta from there. It is approximately comes out to be 0.54, or we can take theta approximately as 30 degree. Okay. Approximately as 30 because 0.54 you can calculate by doing sine inverse, all that thing. So it is comes out to be approximately 30 degree. Get it? Get that? So let's, if you have any question regarding that, you can ask it, or I'm moving to the next question. So this is the question number 16. Let's read the question. It states that the optical excitation of the intrinsic germanium creates an average density of 10 raised to the power 18 conduction electrons per meter cube. So what do we mean by that? We are given with the conduction density, that is NC, or we can say it is like okay, average density of conduction electron per meter cube. Yeah. So here we are given with the density of the electrons, that is 10 to the power 18 conduction electrons per meter cube in the material of the liquid nitrogen. Okay, at a nitrogen temperature. At this temperature, electrons and hole mobilities are equal. So mobilities of electrons and holes are equal, and we are given with mu equal to 0.5 into 10 raised to the power 4 centimeter square volt per second. So here we are given with the value of mu, that 0.5 into 10 raised to the power 4 centimeter square volt second, right? So can you convert it to the some SI unit like meter square volt per volt second? How we can convert it? Yes, you can convert it like this: 10 raised to the power 4 into 10 raised to the power minus 4, because like 1 centimeter square equal to 10 raised to the power minus 4 meter square volt second. So it comes out to be 0.5 meter square volt second. And germanium dielectric constant is given. So dielectric constant 20 is given, right? So diffusion coefficient. So you have learned about the Einstein equation, that um, D, that diffusion coefficient, right? Diffusion coefficient upon the mobility is equals to kbt upon E, right? We need to find the D, that is the diffusion coefficient. Mu is already given to us, right? E is the electronic charge, kb is the Boltzmann coefficient, and we are just need to calculate what is the value of temperature here. Because if we know the value of temperature, we can easily calculate the value of D, that is diffusion coefficient, right? Okay, that's great. So what is the value of temperature? And we are given that at the liquid nitrogen temperature, right? It is given as a hint, right? Sometimes you are given with the data of liquid nitrogen externally, right? External in the sense in the brackets that the temperature of the liquid nitrogen is around 77 Kelvin. It's normal that we are taking as a 77 Kelvin as a liquid nitrogen temperature, right? So temperature of liquid nitrogen is equals to 77 Kelvin, right? So how we can find out the value of D? It is just easy, na? D equal to mu kBT upon E. We know the value of mu here, just put that. We know the value of kb here, that is a Boltzmann constant charge, and now we know the value of temperature, that is 77 Kelvin. So just calculate the value of D from there. What is the value of what is the value of D we will get is, that is around 3.3 into 10 raised to power minus 3 meter. Yeah, it is meter square per second something. So we are giving this value. Okay, this will be the going to be value of D, that is diffusion coefficient. So this will going to be a correct answer. Okay, any doubt related to that this question? I know many students are busy in their celebration Diwali right now. Yeah. Okay, पटाखे पटाखे जो कल फोड़े होंगे आज भी कुछ बचे होंगे तो वो भी फोड़ रहे होंगे, right? So that's great. Diffusion coefficient, yeah. So let's move to the next question. Its unit is like meter square per second. Let's move to the question. So this question belongs to an electromagnetism. It has already came to an JAM examination, right? It is a very easy question. This is a like memory question. We can say that. Here we want to find out the polarizability, right? The polarizability alpha of an electron moving in a circular orbit of radius r about a charge plus c in a field directed at a right angle to the plane of the orbit is. It is said that as we know that atoms in any of the material, there are atoms, right? There are atoms, multiple atoms are there, and in each atom there is a nucleus, right? An electron revolves around this nucleus. We say that this is an electron. This electron revolves around this nucleus. If we are, if we somehow pass the electric field this way, so that the molecule, the shape of molecule like stretched, right? It gets stretched. A dipole will create it like this, or this will become like this. This is the electron. This is the electron, and it is revolving. It creates some dipole moment, right? So the polarization, as we know, is equals to alpha times electric field, राइट? बिकॉज़ जितनी ज़्यादा हम इलेक्ट्रिक फील्ड की स्ट्रेंथ अप्लाई करेंगे, उतना ही मॉलिक्यूल में डिस्टॉर्शन ज़्यादा आएगा, और जितना ज़्यादा डिस्टॉर्शन आएगा, उतना ही ज़्यादा उसका डायपोल मोमेंट आएगा, राइट? So that is the polarizability. It is directly proportional to alpha E. So the question asked to what is the value of alpha, right? What is the value of alpha? And that is a very straight question. It has a matlab, standard question in, if you have ever studied the notes like somehow, you know the value of alpha. It is directly 4 pi epsilon naught r cube. And what is the purpose that I'm taking this question here is that sometimes in the examination, it some memory based question is asked. So here our time is saved if we don't do the derivation, if we know the result previously. Otherwise, this question is like easy, right? If you know the answer, if you know the standard result, you can do it. Otherwise, it is a luck, right? So that's why I have taken this question, so that you know what is the value of the memory based questions, right? Somehow, not every time calculation based lengthy questions are there. Sometimes um, scoring questions like memory based that are easily remembered, that can be students should remember about that, are there, like this one. So let's move to the next question. A radioactive element X decays to Y. X decays to Y, which in turn decays to a stable element Z. Okay. The decay constant from X to Y is lambda 1. The decay constant from X to Y is lambda 1, and that from Y to Z is lambda 2. Okay. This question says that X is decaying to Y and Y is decaying from to Z. Right. So decay constant from X to Y is lambda 1 given as, and from Y to Z it is lambda 2. Right. If there are n naught atoms initially, if there is n naught atom and there were no any atom of the Y and Z, right, at any time t, and it is given a very short time, at any time t, what is the number of atoms of Z? What are the number of atoms of Z that are left, right? Or what are the number of atoms of Z that are created? So we need to find that, right? सर आज टेस्ट देना स्टार्ट किया पर मार्क्स कम आ रहे हैं, क्या करें? देखो, सबसे पहले आपको मीन्स डिप्रेस नहीं होना है, अपना मोटिवेशन बनाए रखो। जब मैंने टेस्ट सीरीज देना स्टार्ट किया था तो मेरे भी मार्क्स कम आ रहे थे, एंड if you're getting low marks, then it is opportunity to get back all those questions, all those your revision notes that you practice late, right? उसमें जाओ और उस कंसेप्ट को दोबारा से रिवाइज करो। उन कंसेप्ट को आप दोबारा से रिवाइज करो जिसमें आपको ऐसा लग रहा है कि आपके थोड़े कंसेप्ट हिले हुए हैं, राइट? अब उनको अच्छे से नहीं आते हैं, उन क्वेश्चंस को आप लगा नहीं पा रहे हो। कभी-कभी कैसा ऐसा होता है कि हम मतलब उस कांसेप्ट के बारे में हम समझ तो लेते हैं, बट क्वेश्चंस नहीं बना पाते, समझ रहे हो? राइट। तो उन कांसेप्ट पे आप दोबारा जाओ और एक और काम करना, जो भी आप टेस्ट सीरीज दे रहे हो, मान लो आपने आज इलेक्ट्रिसिटी एंड मैग्नेटिज्म का टेस्ट सीरीज दिया, उसमें 20 क्वेश्चन आए, 30 क्वेश्चन आए, आपने टेस्ट दिया, टेस्ट देने के बाद एक ए4 शीट लो, ए4 शीट लो या आप एक अलग से नोटबुक बनाओ, उन सभी क्वेश्चंस को राइट डाउन करो, उनके आंसर्स विद क्वेश्चंस भी लिखे होने चाहिए, उनके सॉल्यूशन भी लिखे होने चाहिए। अगर आपको वो क्वेश्चन आता है, आपने अपने तरीके से किया तो आप अपने तरीके से उसका लिखो, राइट? ताकि आपको ये पता चले कि आपने मिस्टेक कहाँ करी थी। उन क्वेश्चंस को करते हुए मिस्टेक कहाँ करी थी, और जब भी आप एग्ज़ाम देने जाओगे, तो उन सभी क्वेश्चंस जो आपने टेस्ट सीरीज़ में अटेम्प्ट किए थे, जो-जो आपने मिस्टेक करी थी जहाँ-जहाँ, उन सबको रिवाइज़ करके जाना ताकि एग्ज़ाम में कोई मिस्टेक ना करो। एग्ज़ाम में कोई मिस्टेक नहीं होनी चाहिए, मतलब वो एक्सेप्ट नहीं कर सकते। अभी अगर मिस्टेक हो रही है, दैट्स ओके। यू कैन ईज़िली टेक दैट ओवर, राइट? अभी आप मिस्टेक कर सकते हो, लेकिन एग्ज़ाम में मिस्टेक मत आना, क्योंकि वो 3 घंटे जो आपके एग्ज़ाम में हैं, वो आपके मीन्स पूरे 1 साल की मेहनत को डिसाइड कर देंगे, राइट? तो अच्छी बात है आपने टेस्ट देना शुरू किया, दैट्स ग्रेट। आई एम वेरी इम्प्रेस्ड दैट आप टेस्ट दे रहे हो, बट कोई बात नहीं, एग्ज़ाम मार्क्स कम आ रहे हैं, दैट्स ओके। धीरे-धीरे आप उस कांसेप्ट पे रिवाइज़ करो। आप आज आपने जो भी एग्ज़ाम दिया, जिस भी टॉपिक का एग्ज़ाम दिया, उस कांसेप्ट पे दोबारा जाओ, कहाँ-कहाँ मिस्टेक करो वो सब देखो, और फिर दोबारा से उसको मीन्स देखना कि क्यों मिस्टेक करी, ठीक है? उस टाइम पे आपका क्या माइंडसेट था कि आप उस क्वेश्चन को सोच रहे थे उसके बारे में, ठीक है? तो वो देखना। तो अभी हम इस क्वेश्चन पे बात करते हैं। एट टाइम t इक्वल टू t, हमें बताना है कि कितने नंबर ऑफ z एटम्स अवेलेबल हो जाएंगे, कितने नंबर ऑफ z एटम्स हमारे पास होंगे। z इज गिवन एज स्टेबल न्यूक्लियर हियर, सो लेट्स मूव। ओके, ओके सर, सिलेबस को रिवाइज कर रहा हूँ पर टेस्ट आज स्टार्ट किया। हाँ, दैट्स ओके। let let me do this question. Okay, so here we are given with the x that decays to y and y is decaying to z. Decay constant is lambda 1 here, decay constant is lambda 2। at t equal to 0 हमारे पास n नोट नंबर हैं x के, y और z हमारे पास 0 हैं। at t equal to any time t, तो नंबर ऑफ एटम्स हमारे पास x के कितने हो जाएंगे? लेट्स से इट इज n1, it is n2 and it is n3. So we need to find the value of n3, राइट? अगर आपने रेडियो एक्टिव न्यूक्लियर फिजिक्स पढ़ी होगी, राइट? आपके मीन्स मॉडर्न फिजिक्स का एक पार्ट है, तो आपने वहाँ पे मीन्स ये पूरी रिएक्शन पढ़ी होगी, आपने कुछ रिजल्ट्स डिराइव करे होंगे, उसमें से एक रिजल्ट ये होगा, राइट? n3 इज इक्वल्स टू n नॉट 1 प्लस लैम्डा 1 अपॉन लैम्डा 2 माइनस लैम्डा 1 e टू द पावर माइनस लैम्डा 2t, राइट? माइनस lambda 2 minus lambda 1 e to the power minus lambda 1t, right? You have derived this result for the number of atoms that are left at any time t after time t for z, right? So this is the same question, but here we are given with the t that is very short. I mean t is very less than 1 upon lambda 1 and also very less than lambda 2, right? So we need to find out this relation. We need to simplify this relation for very less than t. So what we can expand the exponentials here, right? We can expand the exponential, and what we are getting that n naught 1 plus lambda 1 upon lambda 2 minus lambda 1, 1 minus what I can write it lambda 2 t, right? Okay, plus lambda square like lambda 2 square upon t square by 2 factorial. As we know that e to the power of minus x, how we expand that? That is 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial and so on, right? So we are similarly simplifying this expression, right? Minus lambda 2 upon lambda 2 minus lambda 1, 1 minus lambda 1 t, right? Plus lambda 1 square t square upon 2 factorial. Okay, just solve this expression. Solve this expression. All some terms will cancel out each other, right? And what we are left with is n naught. I'm directly writing out the result, that is lambda 1 lambda 2 square t square upon lambda 2 minus lambda 1 into 2, 2 भी आएगा, lambda 2 into lambda 1 lambda 1 square t square upon lambda 2 minus lambda 1 and यहाँ पे आएगा हमारा 2 factorial. Yeah, so we are left with this, and just simplify it. Take out some common terms here, that is lambda 1 lambda 2 upon lambda 2 minus lambda 1 into 2. अंदर क्या रह जाएगा हमारा? यहाँ से हमने lambda 1 lambda 2 कॉमन लिया तो lambda 2 एक रह जाएगा, यहाँ से हमारा lambda 1 रह जाएगा. So it comes out to lambda 2 minus lambda 1 and t square will be here. So this terms will cancel out, means lambda 2 minus lambda 1 will cancel out, and what we are left is n naught is equals to n naught lambda 1 lambda 2 t square 1 by 2. So this is the expression that we are left with, and let us match with the our it is yeah, this is, so option A is going to be correct, right? When you open this expression, I mean when you multiply with this term and when you multiply with this term, these two terms will expand it out. Okay, so let's move to the next question. I think my screen is not visible to you. Something happened. Let me check. Share it again, and that is share. Yeah, I hope it is visible right now. Yeah, now it is visible, right? Yeah, this question is done. If you have any doubt related to that question, if you are done have something like solid state or electronics part, this question is like easy, or if it is, we can say it is a formula based question directly coming. Just put the values in the formula and you will get the required value. And this question says that the effective density of states in the conduction band is given as NC. Density of states is given. What is the value of NC? That is 2.8 into 10 raised to power 19 per centimeter cube. At what temperature? Temperature is 300 Kelvin, right? The value of electron concentration in silicon, electron concentration in silicon is given. Like silicon, it is about 300 at 300 Kelvin is uh, when the Fermi level, okay, is lying 0.22 electron volt below the conduction band edge. And we will let's say that for any PN junction, right? This is like Fermi level. This is E of F. This is Fermi level. This is the conduction band edge. This is the valence band edge. And we are given with the value that EF, that is Fermi level, is lying 0.22 electron volt below the conduction band. Like the, it is given with this energy band gap, EC minus EF. What is the value of EC minus EF? That is 0.22 electron volt, right? So we can write that EC minus EF is equals to 0.22 electron volt. Getting it? Yeah. So what we need to find? We need to find the electron concentration in silicon and T equal to 300 Kelvin. We need to find the electron concentration. So what is the formula? That is N is equals to NC exponential minus EC minus EF upon KBT. So this is the formula where NC is the density of states. That is, we are given with the value that 2.8 into 10 to the 19 per centimeter cube. And the value of EC minus EF is given as 0.22 electron volt. We know the value of Kb. We know the value of temperature. Can we find out the value of N? Can we find out the value of N from here? Right? It's easy, I think. We just need to put the values. We just need to put the values. Make sure before using this 0.22 electron volt, please convert it into the, I mean, into volt, right? It is into joule, sorry. It is electron volt, so you would need to multiply with 1.6 into 10 to the minus 19. So to convert it into the joule, so that you can use the value of Kb correctly and value of temperature as correctly, right? Just put the values of all those values, you will get the value of N. Just find out that value, what you get, right? Find the value of N. I already calculated that. I will write down the answer and just match your answer below. So I'm writing down the answer. The answer is going to be like 5.78. Sorry, 5.68. 5.68 10 raised to power 15 per centimeter cube. By putting the values, we will get the answer directly. You can do the calculations. Okay, so I'm more question. So here is the question number 20. This question belongs to the classical mechanics, right? It is mechanics, or you can say, so moment of inertia is the topic. So two masses of mass m each. Two masses of mass m each are placed at a point xy. That is AA and minus AA. And we're drawing the figure like this. This is like x and this is y. And mass m is placed at, let's say this is m here, and minus a and a. This is m here, right? And two masses 2m at placed at a and minus a. Let's make it y-axis, and this is x-axis. Okay. Okay. So that no confusion. This is mass m, this is x-axis, and this is y-axis. And there are two more masses having 2m mass each are placed at a point a and minus a. So x value is a and y value is minus a. So I'm taking it here, and minus a and a. That is 2m mass is also here. Okay. So these four masses are there, and you need to find out the moment of inertia of the system. That is principal moment of inertia. Make sure you need to find the principal moment of inertia here. And you already know, I'm moving to the next page, and you already need to find the principal moment of inertia. We need to find the inertia matrix. What is the inertia matrix that we learned? That ixx, ixy, ixz, iyx, iyy, iyz, sorry, yz, izx, izy, izz. Once you find out this moment of inertia matrix, you can easily found out the. सर फिजिक्स के लिए मेंटरशिप के लिए कोई कोर्स आएगा क्या? सर फिजिक्स के लिए अगर कोई भी कोर्स आता है तो आपके मीन्स जो कम्युनिटी में पोस्ट डाल दिया जाएगा। अगर कोई ऐसा कोर्स आता है, अगर सर आपके लेके आते हैं, ठीक है? दैट्स तो वो आपको नोटिफिकेशन दे देंगे, एंड यू कैन जॉइन दैट कोर्स। So this is the principal moment of inertia matrix, and to find out the principal moment of inertia, you need to just find out the um, eigenvalues of this matrix, right? To find the eigenvalue of this matrix, right? Once we find out the eigenvalues, these eigenvalues are known as the principal moment of inertia, right? So let's before finding out the eigenvalues, we need to know what is this matrix, right? We need to find the terms like ixx, ixy, iyz. All these terms we need to find out. So what is the value of ixx? It is something like x square, sorry, y square plus z square, right? In ixx there is no term like x square, so it is y square plus z square into dm. So this is like, and we are given with the four masses. Let me draw that here, x and y. Here is mass m that is placed at a and minus a, sorry, a and a. Here is the mass 2m, mass m is here, 2m is here, right? Just put the values to find the value of ixx. What is the y coordinate here? It is like we can say it is a and a, it is a and minus a, it is minus a and minus a, it is like minus a to say a, right? We need to find, as it is in the xy plane, so z coordinate is 0, right? We know that z coordinate is 0. So what is the value of y square that we are getting is, for this mass m, the value of y coordinate is a, so we can write it as like a square m, right, plus the value of a square into 2m. For this mass I am writing like a square, because minus will cancel out when we do the square, right? So into m, and a square into 2m. Just fastly calculate this. 2 do 4, and 4 and 2 and 6. 6m a square. And similarly, what will the value of y square? Iyy. What is going to be the value of iyy? it is similar as IXX, right? 6 MSK, because these are the symmetry axis. IXX is similar like IYY. So we get the moment of inertia will be same. And what is the value of IZZ? Can you calculate the value of IZZ? It's simple, right? It is something like, or we can use a summation sign because it is a discrete, right? Um, so what is the value of IZZ? It is something like x square plus y square into mi. That is I equal to 0, say, let's say n. We are given with the mass, n masses, if, right? So xi and yi. So just calculate that. For all those masses, we can say x square is equal to a square and y square equal to a square, right? So we can say a square plus a square for mass m, and we can say that a square plus a square for mass 2m, right, for this mass. And for this I can write a square plus a square into m, and similarly a square plus a square into 2m. Just calculate the value of IZZ. What is going to be the value of IZZ here? It is like 2 into 4, 6, 6 into 8, 8 and 4, 12. It is like 12 m square. So can you find out the value of I xy? That is, we can write it as summation xi yi into mi minus. Can you find the xy? Similarly, we can find. Can you find out the value of x z y z, and what we are left with? Yeah, these three terms we are left, because zy same as xz. Sorry, zy is same as yz. For this summation xi zi mi, okay, minus sign, minus summation yi zi with mi. As we know, the system is lying in the xy plane, so the value z coordinate going to be 0. So this is going to be 0. This is going to be 0. We are left with just, we need to find the just value of the xy, ixy. Can you find out that? So for mass m, the value of x is a, value of y is a. So we are getting with minus a square m, right? For mass m that is lying at the minus a, when we multiply with it, that will become a square, and with minus sign, it we are also getting a square m. For mass 2m that is lying in minus a, we will get an extra sign minus when we multiply their x and y coordinates, and this minus will cancel out with this. So it becomes plus a square into 2 of m. And similarly for a minus a, we will get like a square twice of m. So this term and this term cancels out, and we are left with 2ma square. Ixy equal to Iyx. So just tell me what is the moment of inertia matrix? That is going to 6ma square, 2ma square, 0, like 2ma square, 6ma square, 0, 0, 0, and Izz was 12ma square. Just find out the eigenvalues for this matrix, right? You can find out the eigenvalues, right? It is easy. But what are the going to be eigenvalues? Let me write that. Eigenvalues, we will get lambda 1 as 4 ma square, lambda 2 as 8 ma square, and lambda 3 as 12 ma square, right? So these are the eigenvalues. And what the question asks, we need to find out that. So we are getting like 4 ma square and 8 ma square, right? 4 ma square and 8 ma square. This is the option. So these are the principal movement of inertia, because there is also one we get to 12 ma square, but only two options are given, so we can just match with this option, right? So for the correct answer is question number option B. Option B will be the correct option. So let's move to the next question. That is question number 21. Question is from the electricity and magnetism part. It is something it has to do with the mathematical physics, because in this question we need to solve some differential equation. Okay. Yeah. But the concept used here are of the electromagnetism, EMT part. So this question says that the electrostatic potential V and xy in the free space in any region where the charge density rho equal to 0. Remember this thing. Whenever the charge density is 0 in electrostatic potential, then we can think of applying the Poisson bracket. Del square V equal to 0. Right? This is the Poisson equation. Always remember, whenever the charge density is 0, instantly your mind should click that. Wait a second, what is going? Your mind should be clicked that we need to use the Poisson bracket somehow. Okay. And it is also given that V of xy equal to this. This is the potential, and we need to find out the value of fx here. Okay, we need to find out the value of fx, given that the x component of the electric field is 0. X component of electric field is 0, and the value of potential at the origin is 0. What do you mean by potential at origin? That put the value of x and y equal to 0, but we are left with f of 0 plus 4 and minus 3. This is equal to 0. So f of 0 is equals to minus 1, right? One boundary condition we have used, and second boundary condition, the x component of electric field is 0. Just find out the x component. How we find out the electric field? That is del dot v minus of del dot v, or we need the x component, so we just need to find the del upon del x minus of v. Just find out this value. That is going to be minus of 8 e to the power 2x plus f of x. I mean, f of prime x, we just differentiate with respect to x, because f is a function of x only. This value is given, and x component of electric field at its origin is going to be 0. That is equals to, when we put x equal to 0, we get minus of 8 minus of f prime 0, right? So this we get f prime 0 equal to minus of 8. This thing we get. सर मेरा ईएमटी और ऑप्टिक्स क्वेश्चन प्रैक्टिस और फर्स्ट रिवीजन बाकी है, इन टॉपिक्स का अब से क्या फॉलो करें कि टॉप आईआईटी में हो जाए? देखो मेरी बात सुनो, ऑप्टिक्स में सबसे अच्छे से आपको करके जाना है जो हमारी वेव ऑप्टिक्स होती है, जिसमें हम यंग डबल स्लिट एक्सपेरिमेंट, ग्रेटिंग और डिफ्रैक्शन के बारे में पढ़ते हो, तो ये सब चीजें आपको करके जाना है. सेकेंडली, देर इज वन इंपॉर्टेंट थिंग, दैट इज पोलराइजेशन. आप पढ़ते हो राइट हैंड पोलराइजेशन, लेफ्ट हैंड पोलराइजेशन, क्वार्टर वेव प्लेट, हाफ वेव प्लेट, ये सब करके जाना. मीन वेव ऑप्टिक्स आप अच्छे से करके जाना. ठीक है. सर आपका नंबर विल टेल यू सून. लास्ट में बताऊंगा, लास्ट तक रुकना. ठीक है. तो ये तो वेव ऑप्टिक्स में करके जाना. ईएमटी में इलेक्ट्रोस्टैटिक मैग्नेटोस्टैटिक तो करके ही जाना भाई. यहाँ से बहुत खतरनाक क्वेश्चन बनते हैं. क्योंकि यहाँ पे जो मैग्नेटोस्टैटिक्स की आपको फिगर दी जाती है, कैलकुलेट द मैग्नेटिक फील्ड एट पॉइंट ओरिजिन और समथिंग लाइक दैट, किसी एक पॉइंट पे मैग्नेटिक फील्ड निकालना या इलेक्ट्रिक फील्ड निकालना, तो ये काफ़ी अच्छे क्वेश्चन बनते हैं इनसे। तो ये करके जाना, आपसे बात करना है। 10th क्लास का पढ़ा दो। 10th क्लास का क्यों पढ़ाऊँ भाई? ठीक है, तो अभी अब क्वेश्चन पे कंटिन्यू करते हैं, डिस्कस इट लेटर। अच्छा, सभी चैप्टर के अगर आपने एक-एक बार रिवीजन कर ली है, तो आपको क्या करना चाहिए? ओके। फिर आप टेस्ट सीरीज अगर आप दे रहे हो, राइट? टेस्ट सीरीज दे रहे हो आप? आप एक बार टेस्ट सीरीज दो, क्योंकि आपको मीन्स अगर आप क्वेश्चन प्रैक्टिस कर चुके हो अच्छे से और रिवीजन भी हो चुका है, आप टेस्ट सीरीज देना शुरू करो, ज़्यादा लेट मत करो, ठीक है? क्योंकि आपको टाइम प्रेशर हैंडल करना होना चाहिए। कल स्टार्ट करूँगा, अच्छी बात है। सर बेस्ट कॉलेज फॉर ईसी, आई मीन ईसी, ईसी मीन्स इलेक्ट्रिक, वी विल डिस्कस इट लेटर। We need to first focus on our questions, okay? We will discuss later all the things. So this is f of 0 and this is f prime 0. We get these two things. And one more thing, one more equation we will get, that is we can use del dot E equal to that is equal to rho upon epsilon naught ना. तो charge free region है. Charge free region means density equal to 0. Density rho charge density equal to 0, so we can say del dot E equal to 0, right? Or we can say del square V equal to 0. Poisson bracket. Just double differentiate this equation, right? Just find out the Laplace, apply the Laplace operator on v of xi, right? Del square v and put it equal to 0. We will get a second order differential equation. We need to solve this for f of x. Okay, just solve this equation. What are we given with the v? V is given as 4 of e to the power 2x plus f of x, right? Minus of 3y square. So something we can like del 2 upon del x2 plus del 2 upon del y2 into v equal to 0, right? Just do it. It will come out as 16 e to the power 2x plus f double prime x plus, when we double differentiate with respect to y, we will get um, and minus 6 and 6 equal to 0. We need to find the value of f double prime. So we can do is f double prime x equal to 6 minus 16 e to the power 2x, f prime x equals to 6x. When we integrate with it with respect to x, we will get minus of 8 e to the power 2x, right? By integration with x and some constant c. And we know what is the value of f prime x at x equal to 0. F prime x at x equal to 0 is minus 8. Just put the value of x equal to 0 here. That is going to be minus 8 e to the power, that is going to be 1, right? So 8 over 2x will become 1 at x equal to 0 plus c equal to minus 8. So c is going to be 0. So f prime x is equals to 6x minus 8 e to the power 2x, right? The value of c is going to be 0 and I put that. Now integrate again with respect to x. So when we integrate with respect to x, what we will get? 6x square by 2, that is 3x square minus 4 e to the power 2x plus c. And what is the value of f at x equal to 0? When we put x equal to 0, this will 0 and minus 4 plus c will become, right? What is the value of this we will get like f0 is -1. This is -1. So c is equal to 3. So what we are left with, f of x equal to 3 of x square minus 4 of e to the power 2x plus 3. Right? So what is the correct option? I think no option is matching here. I think I did some mistake or something. Electric field of x thing 8 plus f prime x, and put it to 0. This is correct. This there is a mistake. Here is a mistake in calculating the f of 0. When we put x equal to 0, this will become 4 f of 0, and when we put y equal to 0, this will become 0. So this will become 0, and f of 0 will become minus of 4. And here we put minus of 4, so c becomes 0 here, and this thing we get as 0. So f of x comes to be this. So now D option is matching, right? So correct option is D here. So I am moving to the next question here. शक्ति स्वरूप प्रधान, मैं आपको अपना नंबर दे दूंगा, ठीक है? आप मुझे व्हाट्सएप कर देना. We will discuss it what is going to be the strategy for TIFR, and you can discuss the doubt in on the WhatsApp. You can message me there. Okay, I will share my number. So question number 22 says that a ball weighing 100 gram released from a height of 5 meter bounces perfectly elastically off a plate. Right. Here is a ball given. Right. This is a ball. This is the ground. Mass of the ball is given as 100 gram. Right. Height. At what height? Height is 5 meter. Right. Height, that is this height is 5 meter. Bounces perfectly elastic. When it comes to the ground, it collides with the ground and bounces elastically. Means coefficient of restitution is equal to 1. So collision time between the ball and the plate is given as 0.5 second. The average force on the plate is approximately. We need to find the average force, or you can say the force is given as by the Newton's second law, change in momentum upon change in time. The one thing you know that initially the momentum is in the minus y direction, and what is going to the momentum, that is mv. And when the ball gets struck to the ground and it moves in the positive y direction, right, with the same momentum, because velocity will no change because it is elastic collision. So what is the total change in momentum? Total change in momentum is going to be like, first it is going in the minus 5 direction, right? That is final momentum minus initial momentum. So what was the final momentum? I am taking momentum in the y direction as positive, minus, and initial momentum is minus mv. It's come like 2 mv. Okay, that is change in the momentum. So when we put the value delta p here, delta p is like we've recently calculated 2 mv upon change in that is time, that is 0.5 second, right? We need to just need to find out the value of velocity here. So velocity for any ball, right, for anything that is dropped from any height h, we can say that it is like 2gh. How it is coming? We can just compare here. Here the kinetic, here total energy is just like potential energy when it is at the rest. So we can compare that mgh equal to half mv square, right? by using the energy conservation, and you can find out the velocity. It comes out to be under 2gh. We know the value of h, we know the value of g, we know the value of the 2 is there, right? Just find out the value of v. It's come to 2 into 10 into h. What is the value of h? It is 5. So v comes out to be 10. Just put the value of here. So f is like 2 into 100 gram. We can convert it into the kilogram, and with multiplying with 10 and 0.5, right? So it becomes like 4. 4 Newton is going to be the answer. So correct option is D. Okay, so let's move to the question number 23. Assume that E versus K relationship of electron in a conduction band of hypothetical tetravalent an atom, right, can be expressed by this relation, right? So we can say that dispersion relation is given to us plus constant, something constant is there, right? And we need to find the cyclotron resonance for electron in a field B. Magnetic field लगा रखा है cyclotron, and you think you have studied this about the cyclotron frequency and all those things in your 12th class, right? So what is the cyclotron frequency? That is EB upon M, right? Where E is the charge of an electron, B is the magnetic field that is applied, and M is the mass. But here the dispersion relation is given to us. We need to find the effective mass. And what is the value of effective mass? That is h cross square upon d2E upon dk2, right? Double differentiate of E with respect to k. Find out, can you do the double differentiate? We will get the 2A from here, right? When we put it the value here, we get like omega is equals to EB upon h cross square into 2A, right? We know the value of omega. It is given as 1.8 into 10 raised to power 4. We know the value of omega. We know the value of charge. We know the value of magnetic field, right? We know the value of h cross. We just need to find the value of A. So omega h cross square upon 2EB, right? Can you find out the value of A from there? We know all those values. You can easily find out the values of A, and it's come out to be like 6.2 into 10 raised to power minus 38 joule per meter square. You can just put the values and from the formula, and you can find out the value of A from there. It's easy, right? So I'm moving to the next question, which says that two particles of identical mass move in a circular orbit under a central potential V equal to half kr square. Let L1 and L2 be the angular momentum and R1 and R2 be the radii of the orbits respectively. So we need to find the value of L1 by L2. We need to give with the potential, right? It is a problem of central potential. If you have ever studied about central potential, right? In the classical mechanics, there is a chapter, central potential, right? Central forces. You know about the central potential, right? Which depend only on the value of R. Angular momentum are L1 and L2, and radius are R1 and R2. They are moving in the circular orbits. Circular orbits, right? It means if we find out the something effective potential, what is the effective potential? That is L square upon 2mr square plus of half kr square, right? If we differentiate with respect to r, right, to find out the radius of the circular orbit, right, and put it equal to 0, and del v upon del r, that is v effective, equal to 0 for the circular orbits, right? So we can easily do like L square upon m r cube plus k of r equal to 0, where L is the angular momentum here, right? So can we find out the value of L here? Can we find out the dependence of L on R? Let me do it. Kr equal to L square upon M R cube. So L square equal to M into K R ki power 4. So we can say L square is directly proportional to R ki power 4. Or we can say L is directly proportional to R ka square. So L1 upon L2, it means R1 upon R2 ka square. So so the value of L1 upon L2 is given as 2. We need to find the value of R1 and R2. R2 का स्क्वायर गिवन है. So R1 upon R2 कितना हो जाएगा? That is root 2. Right? You can match the answers here that it is root 2. Correct option is option A. Right? So here it is a question number 25. The question number 25 says that a uniform magnetic field in the positive z direction passes through a circular wire. We are having a circular wire. Like this is a circular wire. Magnetic field is in the positive z direction. Z direction. ठीक है? Radius of the loop is given as 1 centimeter. Right? So what is the value of radius here? That is 1 centimeter, or you can say 0.01 meter. Resistance R. I am denoting resistance with capital R. That is 1 ohm, lying in the XY plane. The field strength is reduced from 10 Tesla to 9 Tesla. I mean, the value of magnetic field is changing. That is from 10 Tesla to 9 Tesla in 1 second. The change transferred, there is a charge, not change, charge is there. We need to find that the how much charge that got transferred from any point in this second, in a second. And we know that change in magnetic field produce an induced EMF, right? That is epsilon is equal to induced EMF, that is equal to minus of d phi by dt, right? Change in magnetic flux with respect to time. And what is the value of flux here? It is just simply like magnetic field into area. Is area going to change with time? No, area remains the constant. And what is going to be changed with time is magnetic field. So we can write that epsilon equal to area into dB upon dt minus of, right? And if we need to find the charge transfer, I can write current equal to, that is voltage, that is EMF induced upon resistance, right? So this can be written as minus A upon R dB upon dt, right? So next page we will do. So I is equals to E upon R, that is equals to minus A upon R, change in magnetic field with respect to time. And I can write that dq upon dt equal to minus A upon R dB upon dt. So we can cancel out this dt, or you can integrate with respect to t. So dq, that is charge, is equal to A is the area, R is the resistance, and magnetic field change, right? So change in magnetic field is, it is decreasing, right? From 10 Tesla, it comes to the 9 Tesla. Like final minus nation, 9 minus 10, it comes out to minus 1. So we can write it is equals to A upon R. What is the going to be the area? Area is just like pi R square upon R is 1 ohm. So 3.14 into 0.01. Just calculate this here. You will get the charge transfer. It is approximately like 3.14 into 10 raised to power minus 4 coulomb. Right? So this amount of his charge is getting transferred from any single point, because change in magnetic field produce induced EMF, and induced EMF will produce electric field. Electric field will flow the charge, right? because if there is a current flowing, so charge will be flowing there. So this question is question number 26. Uh, A uniform magnetic field in positive z direction passes through a circular Q. Circular, so this is not a mistake there. So, passes uniform magnetic field in positive z direction passes through a circular. I mean, this is some typing problem there, so I'm skipping this question for now. I mean, I'm going to skip this question for now. I will correct it and then I will inform you about this question. Question number 26. Okay, we'll give you in the homework. There is some mistake in this question. So here comes the question number 27. If the operators A and B satisfy the commutation relation, that is, commutation of A and B is equal to identity, right? We need to find out which option is correct one. As we know that e to the power A is equals to, just need to do the exponential expansion, right? We can write 1 plus A plus A square upon 2 factorial, A cube upon 3 factorial, and so on. And we need to, if we find out the value of EA with respect to B, we can write it E with this 1 with respect to B, that is commutation of 1 with respect to B plus commutation of A with respect to B, plus 1 upon 2 factorial commutation of A square with respect to B, and so on. Commutation of any operator with a constant comes out to be 0. So first term is 0. Commutation of A with respect to B, commutation of A and B is given as identity. So I can write it as identity, right? So second is 2A commutation of A square with AB. We can write it like twice of A upon 2 factorial A and B, right? And this term will correspond to A and B will become I, and 2 and 2 and get cancel out. This will become A. And if you solve something other than this, or if you take more than two terms, like let me just take the third term also, that is 1 upon 3 factorial A cube and then B. And this term will give you 3A square upon 3 square upon 3 factorial commutation of A with B. This term will goes to identity and it will give you A plus A square by 2, because 3 will cancel out, only 2 remains there. So we will get this. And if you get if you solve more number of terms, you will get something like this: A upon 3 factorial, then A upon 4 factorial, A power 4 upon 4 factorial. You will get all those terms, and this will correspond to the e to the power A, like this. So the correct option is option number A, that commutation of exponential of A with B is comes out to be exponential of A. Okay. So this question is going to be the last question. Question number 28. This question says that a small magnetic needle is kept at 0, 0. Like if we have xy axis like this, and movement of its along the x-axis, right, is along the x-axis. This is the, let's say this is the our magnetic moment dipole. It is placed at the origin, right? And there is a very small magnetic needle. There is another magnetic moment at a point at 1, 1. This is the point, let's say 1, 1. This is the point 1, 1, and it is free to rotate in the xy plane. We need to find the equilibrium angle theta between the magnetic moment and it's such that, right? We need to find the equilibrium angle theta when they are at equilibrium position. Let's say this is the another dipole that is placed at a 1 1. So this angle is going to be 45, right? This is the position vector, this is the 1 1 point. And if I do this like this, right? So what is the value of this going to be? Can you find out the equilibrium angle? For the equilibrium, we can find out like the potential energy of both the dipoles. We can take a derivative with respect to r and put it equal to 0, right? We can find out the value of theta from there. Can you find out the value of theta? Can you try to find out the interaction potential energy between these two dipoles? What is the value? Where is the theta? This is theta, right? That is the angle between this magnetic dipole and this dipole. Like we can say that this is the dipole at 1 1, and this is the dipole at origin, and this is the angle theta. So what is the value of this angle? It is like theta minus 45. Na? By geometry, we will get that easily. So we need to find the equilibrium angle, or we first need to find the potential energy, that is interaction potential energy, that is mu naught upon 4 pi r cube m1 dot m2 minus 3 m1 dot r cap, or we can say this is the r1, or this is the r, right? And m2 dot r cap. So what is going to be the value of m1 and m2? If we assume both the magnetic moments have equal magnetic moment of equal magnitude, so we can take mu naught upon 4 pi r cube m1 m2. If we take the both the moments equal, so we get m square common. It becomes cos theta, right? Minus, where theta is the angle between the both these dipoles, that is theta. M1 dot r cap. This is cos 45, right? Into 3 of cos of 45. And M2 dot r, this is M2 and this is r. What is going to be value between this M2 and this value r? As we know, this is the theta minus 45, na? So these values will be equal. So cos theta minus 45. Okay, let's move to the next page ones. We find out the value of u, that is mu naught m upon 4 pi r cube cos theta minus 3 of cos 45 cos of theta minus 45. Can you differentiate this u with respect to theta and put it equal to 0 to get the stable equilibrium position, right? To get the stable equilibrium position, just do the differentiate u with respect to theta, but we will get mu naught m upon 4 by r cube. Differentiate cos theta with respect to theta, we get minus of sine theta. Cos 45 is something like 1 upon root 2. That is 3 upon root 2, and we'll differentiate with respect to theta, we get sine theta minus 45, and we can do it in a plus and put it equal to 0. Now can you solve that question? We want to sine theta plus minus of sine theta plus 3 upon root 2 cos, sorry, it is sine, not cos. We will get sine theta minus 45 equal to 0. So I can say sine theta. Can we expand this like sine theta plus 3 by root 2 Sin of A minus B. Sin of A cos of B minus uh, cos of A sin of B equal to 0. And what is the value of A? We can put it equal to A equal to theta. I'm just replacing this sin theta here. This is like cos 45. Cos here it comes out to be theta and it is 45. Just put the values. So minus sin theta plus cos 45 is 1 by root 2 and 1 by root 2, 1 by root 2 will become 2. So 3 by 2 of sin theta minus, so here it is minus sin 45 is again 1 by root 2, so 3 by 2 cos theta equal to 0. Can you solve this? So it is comes out to be 1 by 2 sin theta equal to 3 by 2 equal to 3 by 2 cos theta. So 2 cancel out, sin theta. So tan theta equal to 3, something like this. Yeah. So the correct option is tan theta equal to 3. Yeah. Correct option is C here. Okay. So this was our last question. And some students are asking my number, right? So let me give it to you. It is 95888561 If you have any query, I think Shakti Swaroop, na? Yes, Shakti Swaroop was asking my number, so you can note it down. And you can WhatsApp me whatever you want to ask from about your preparation strategy, right? Sir, COT preparation की 2025 प्रिपरेशन कब से करना चाहिए? आई मीन प्रिपरेशन कब से करना चाहिए मीन्स आप अगर जैम की प्रिपरेशन कर रहे हो तो सीयूटी की प्रिपरेशन साथ के साथ ही हो रही है ना, राइट? जो जैम जैम का सिलेबस है वही सीयूटी पीजी का सिलेबस है। जैम की प्रिपरेशन आप अच्छे से करो तो आपका सीयूटी पीजी भी अच्छे से निकल जाएगा। ओके, एनी अदर थिंग यू वांट टू आस्क? एनीथिंग यू वांट टू आस्क फ्रॉम मी और यू हैव एनी डाउट रिलेटेड टू दैट सेशन? सर यही बता दीजिए टीएफआर का कैसे करना है। देखो शक्ति, ना सबसे पहले तो आप अपनी जैम की तैयारी करो, ठीक है? जैम की तैयारी अगर आपकी अच्छे से होगी है, सारा सिलेबस आपका कवर हो चुका है, तो आप टीआईएफआर की पीवाईक्यूज देखो। आपके पास टीआईएफआर की अगर कोई बुकलेट है जिसमें टीआईएफआर के पीवाईक्यूज गिवन है, राइट? तो आप उनको प्रेफर करो। और यूट्यूब पे मीन्स कई सारे यूट्यूब पे मिल जाएंगी वीडियोस जिनमें आपके टीआईएफआर के पीवाईक्यूज सोल्व करवा रखे हैं। और सीएसआर नेट वगैरह के क्वेश्चंस देखो जो आपके जैम के सिलेबस से मैच करते हैं, राइट? बिकॉज हमने अभी तक सीएसआर नेट का सिलेबस आई मीन कुछ टॉपिक्स ऐसे हैं सीएसआर नेट के जो आपके मीन्स बीएससी लेवल से थोड़े से ऊपर के आते हैं, तो उनको छोड़ के आपने जो भी जैम के लेवल के क्वेश्चंस करे हैं, बिकॉज ये टाइम अभी ये है कि आप नई चीजें नहीं सीख सकते उसमें ना, राइट? आपने जो चीजें पढ़ी हैं जैम के सिलेबस में, आप उनको अच्छे से प्रिपेयर करो और जितने भी क्वेश्चन पीवाईक्यू से रिलेटेड हैं टीएफआर के अंदर जो आते हैं, आप उनको प्रैक्टिस करो, ठीक है? हाँ, अगर आपको टीएफआर की तैयारी करनी है तो बाकी मेन फोकस तो जैम ही है। अच्छा, अच्छी बात है। टीएफआर आपका इजीली क्लियर हो जाएगा मैम। टीएफआर में अगर आपको जैम का अच्छे से पढ़ा है तो टीएफआर आप आराम से निकाल सकते हो, ठीक है? कुछ मीन्स कुछ सिलेबस उसका सीएसआर के साथ मैच करता है, थोड़ा एमएससी लेवल का है, तो उसमें आपको थोड़ा-सा मीन्स डिफिकल्टी हो सकती है उन क्वेश्चन को सॉल्व करने की, बट डोंट वरी, अगर आपने जैम का पढ़ा है अच्छे से तो आप कुछ क्वेश्चंस को आसानी से कर सकते हो। थोड़ा-सा दिमाग लगाने की ज़रूरत होती है। सिलेबस अभी ऑप्टिक्स और ईएमटी बाकी है, उसके बाद टीएफआर, पीवाईक्यू थोड़ा देखूँगा। हाँ, कर सकते हो। देखो ईएमटी और ऑप्टिक्स दोनों इम्पोर्टेंट है। ऑप्टिक्स तो ख़ासकर जो उसमें वेव ऑप्टिक्स आती है, उसको कभी मत छोड़ना। उसमें यंग डबल स्लिट डिफ्रैक्शन पैटर्न अगर वो पढ़े हैं तो क्वेश्चंस आप अच्छे स्कोर कर सकते हो। और टेस्ट सीरीज़ देते रहना, ठीक है? टेस्ट सीरीज़ को मत छोड़ना, इम्पोर्टेंट होती है काफ़ी। आपको वो टाइम प्रेशर हैंडल करना सिखाती है। हाँ, मतलब मैं जिस कॉलेज से बिलॉन्ग करता था, वहाँ पे भी मीन्स बहुत ही कम लोग प्रिपेयर करते थे जेईई के लिए। ओके, आई मीन ऑलमोस्ट मोस्ट ऑफ देम आर गोइंग फॉर द गवर्नमेंट एग्ज़ाम प्रिपरेशन दैट वाज़ सो बहुत ही मीन्स कम लोग थे जो अवेयर थे जेईई एग्ज़ाम के। ओके, इट्स गुड दैट यू आर डूइंग समथिंग ग्रेट। जस्ट प्रिपेयर दैट, ओके, या। So Shakti, you can message me on my WhatsApp if you have any doubt related to that, right? We will discuss. So right now I am ending this live stream. Okay, great to interact with all of you. Right? I hope you also enjoy this session. So good night. Bye.